Okay, sorry, I had a student who came in, so I have to continue the video now. For number 2, we're going to simplify the fourth root and isolating the fourth root on top first, and we're going to rewrite 16 as 2 to the fourth. And then on the bottom, we have the fourth root of x to the 14. And so we know that top, we're just going to have 2 because the 4 and fourth root cancels out, and we have a fourth root of x to the 14 on the bottom. So this is going to be a little tricky on the bottom. We want to simplify by canceling any roots from the bottom. So the next root that I'm going to have that will be a perfect 4 is going to be 16. So I'm 2 away from that. So I'm going to multiply the top and bottom by the fourth root of x squared. So that way on the top I just have 2 fourth root of x squared, and on the bottom I will have fourth root of x to the 16. 14 plus 2 is 16. Notice that 16 divided by 4 is going to give me an even x to the fourth power on the bottom. And then we just have 2 to the, for the x squared, it's going to be 2 out of 4, but we can actually reduce that to 1/2. So we just have x to the 1/2 on top. And that is the final answer. For the next problem, it's a word problem. So a frequency f in hertz at which a simple pendulum is given by this function. So let me write down 1 over 2 pi times the square root of g over L, where g is the strength of the gravitational field at the location and L is the length. So formula part A says rewrite the formula so that it gives the length L of the pendulum in terms of g and f, which means we're going to have to solve for L. And so let's go ahead and start by multiplying by 2 pi, because we know that that should be the first thing that we do to get rid of that 2 pi by itself outside. So multiplying by that will give us 2 pi f equals square root of g over L. Next thing we're going to do is square both sides so that we can get rid of the square root. So we have g over L is equal to distributing the square through, it'll be 4 pi squared f squared. And we can actually put a 1 underneath and cross multiply both sides. So we will have L 4 pi squared f squared equals g. And we want to move 4 pi squared f squared to the other side so that L can be by itself. So by doing that, I have L is equal to g over 4 pi squared f squared, and that is the function of L as a function of g and f. Next, part B says to simplify the formula using the fact that the gravitational field is approximately 32. So since we know that g is the gravitational field, we're going to let g equals 32 on top, divided by 4 pi squared f squared, and that will give us 8 over pi squared f squared. So this is the simplified formula. Next, says use the equation found in part B to find the length of a pendulum to the nearest root with a frequency of 0.52. So we know that frequency is f in the formula, and so we're just going to continue and substitute 0.52 into the formula and go ahead and simplify and do the calculation, which will give us the length is going to be about 3 feet long. And so that is the final answer. And now you need to pause this video and try this next problem before you actually look at the answer. Okay, now that you have had a chance to try the problem, we're going to solve it to see if you got it right. The surface area as a function of volume for a box with a square base and a height is twice the side length given by this formula. So we're going to rewrite the formula down here. Says write the approximate model with the coefficient rounded to the nearest hundreds. So we want the volume actually to be separated by itself. So keep in mind that we're going to want to isolate that V. So we should start by distributing that power 2/3 to top and bottom. So we will have 10 and then V to the 2/3 over 2 to the 2/3. And then we're going to have, I'm actually going to combine the 10 into the top. And we have 10 V to the 2/3 over 2 to the 2/3. So again, we want to isolate variable V, so we're going to have to multiply all of this together. And so simplifying 10 divided by 2 to the 2/3, we will have S is approximately 6.3 V to the 2/3. And that is the model with the coefficient rounded to the nearest hundreds. We actually will just leave it at 6.3 V to the 2/3. And that is the final answer. And now your assignment is going to be on over here to the book set for day 2, and then continue working on your HRW and copy notes for 11.3. And don't forget about Alex. Have a good day.